Linux desktops and HPC clusters. He's from the University of Stellenbosch, so feel free to ask him a lot of questions, even if it's not related to this. That's that's what his colleagues from Stellenbosch asked me to say. Even if it's science questions or arithmetic, go ahead, feel free. He's a nerd, but that's what I've been told. Thank you very much, Charl. Good.
Cool. Thanks. Hi, everybody. My name is Charl from the University of Stellenbosch. And today we'll be talking about Puppet. And I use Puppet at the university to manage my Linux desktops and my HPC clusters. We'll be talking a bit about what is Puppet, what are the infrastructure requirements. We'll go through a normal configuration structure. I'll show you what the process flow of a normal run is. We'll talk a bit about how we integrate it on campus and how we deploy it, and I'll do a small demo for you. So Puppet, and this is straight from learn.puppet.com. So Puppet manages your infrastructure for you. You describe configurations in an easy language. It's really, really simple. I'll show you now. And that declarative language is read and applied by your agents. Puppet brings your machines to a desired state and keeps your machines at that desired state. I have machines in the Department of Mathematics that I have not physically seen in 2.5 years. But I know for a fact that they work because they report to me every 6 hours that the LDAP configuration is correct, NTP is correct, etc., etc., etc. But I know for a fact that they work. Even though I change all my settings every now and again because LDAP changes over time, NTP changes over time, and I need to push out new pieces of software, I know those machines work, even though I haven't seen them in 2.5 years. So the infrastructure requirements are really, really minimal. By default, you need about a gig of disk and 2 gigs of RAM for your central configuration server, the Puppet Master. If you're going to be running uh, a large master with thousands of clients, push that up to about 8 gigs. I run 4 gigs of RAM with 4 cores, and I've got on the order of 500 clients, and it's idling most of the time. For the network people, you only need one port open, TCP port 8140, and that is for the HTTPS communications between the clients and the master. The Puppet database is optional. It's really, really recommended because it gives you a lot of really awesome features, but it's completely optional. You can run it on a separate machine if you really, really want to. It's based on Postgres. It's a little service that runs on top of Postgres, or you just run it on the same machine. I run my master and my database on the same machine in the same 4 gigs of RAM. It also only needs 1 gig of disk, 1 gig of RAM, and it has a TCP port that the master uses to speak to the database. So that port doesn't even need to be open to the rest of the campus if it's the same machine. And then your clients. So the clients can be Linux or macOS or Windows. There are even people that run this on Solaris. The client is quite lightweight. I checked the other day for Ubuntu, it's a 108 meg install, and you can either run it as a service or you can run it from cron. So just every 30 minutes or every 6 hours, every 24 hours, depending on how you set it up, it just runs once, applies, reports, shuts down. So it doesn't use any resources when you're not using it. So the configuration structure, there are a number of things in the configuration structure. Your Puppet agents supply the server with facts about the machine. And these facts are things like, what is the OS? What processes exist? Give me all the DMI data, like what the number of RAM sticks you have, that type of thing. The number and identities and configurations of all your network interfaces. And also returns things like uptime and the host's SSH keys. And if you ask for the OS facts, for instance, you'll get a structure like that back. And in your Puppet configs, you can then say, for every machine where OS dot architecture is x86-64, apply the following. It's a really, really nice way for the client to be able to supply the server with facts about itself. All the rest of the configurations I'm going to show you now is all things that happen on the master. Facts are the only thing that a agent supplies to the server. All the rest are in your manifests on the server. So the server, at the most basic, you will define resources. So you want to be able to manage a package, like the NTP package or Open LDAP as a package, a software package. That's basically what it is. Or you want to manage a service, or you want to execute something, or you want to make sure that a certain drive is mounted, or you want to enable a cron or get the SSH key, or you want to create a user. These are the types of concrete resources that are built in and that we can uh, configure with a small little resource declaration like that. So in this case, I will be creating a user sysadmin. It has to be present. The name of the user system administrator. It has to be in the user's GID group. That's the home directory it has to be in. It has a specific shell. The system has to create the home directory for me if it doesn't exist. So if you have users, millions of users, and you want to create them by hand like this, you can, but you don't want to necessarily create the home directories because some other process did. You can say they manage home false. Also, if you say ensure that this user is absent, and you say manage home is true, it'll also delete the home directory. So it's a bit dangerous, that one. And then you can also set the password. I use this to synchronize the root password on all my machines. Every week or so, I just put a new hash in there. Resources are packaged up into classes. Classes are groups of related resources, and these resources are always assumed to be independent. They can apply in any order. I'll be showing you that in the demo later. The first time that we run through the demo, it should fail because they apply in the wrong order. Here you'll see that I have two resources that I have defined. So I define that the package cups has to be installed, and I also define that the service cups must run and must be enabled, and it depends on the package cups already being there. So in this way, I have enforced a relationship between the two. Puppet now knows it first has to install the package, then it can go check whether the service is running or not. Otherwise, it might try to start the service, fail, and then install the package. Classes are groups of related resources. Modules are groups of related classes, and they're cohesive, self-contained things. So you would go to, for instance, the Puppet Forge, which is almost like a marketplace. But you go to the Forge, and lots of people, including Puppet Labs themselves, have written modules there for you to be able to simply control multiple aspects of your infrastructure. Like Puppet Labs have created an NTP module. That module has a number of classes inside to handle configuration, installation, your service for a number of operating systems. They handle Ubuntu, Debian, all the Red Hat flavors, and I think they do Solaris in that one as well. So your modules are the basic structure that if you are starting with Puppet, that is basically where you start. You get yourself a nice module that somebody else wrote, you enable that, and it handles your NTP for you. If you want to get fancy, then you start going down into building your own classes and writing your own resources. Modules are where most people start. Now, the system has a structure called environments. With a single server, you can control the configuration of multiple environments in your environment. Yeah. So you will have a configuration directory for your HPC with all the modules and resources and configurations in there. And another directory for your campus machines with all the modules, they could share them, and configurations and data for campus. And you could have another environment for something else. In the demo I'm going to show you later, I've got a production environment, which is the default name for a system. There's a little demo environment, and I've got a campus environment. So, and you can switch your machines between environments. So it makes it really nice for you to be able to test new systems, test new modules. You make a copy of your production environment, call it test, take one of your agents, point it against test, make changes, see it doesn't actually break your agent, and then you can take the changes from test into production. Hyra. Now, Hyra is a really nice technology. It gives you hierarchical configuration management. I have actually only implemented this part of Puppet last week. I was doing everything the really old way because I don't have time to upgrade all my configurations all the time. And when I realized that I actually have to tell you about Hyra, I decided let's implement this. I found out it is so nice, it is so powerful that I've already converted all of my other machines to Hyra. So a lot of what you will see on the internet, if you Google for configurations, will not include Hyra yet, because it's not all that mainstream yet. But in the new versions of Puppet, from version 4 onwards, it is the preferred way of doing your configurations. So basically what Hyra is then is your key value lookup tool for configuration data, and it allows you to set common configurations and then override those common configurations per node or per architecture or OS name, in a very nice way. In uh, yes, and how Hyra then applies your configurations. It will start at the top of the hierarchy. It knows it's looking for, say, for instance, the name of your NTP server, and it'll go through the entire hierarchy. And the first time that it finds the name of your NTP server, that's the one it'll apply. So if you have a specific NTP server for a specific node, it'll find that. Otherwise, it'll drill down all the way to common and get your fallback. Any questions so far? Cool. So the first time your agent speaks to the server, it generates itself a private key. All communications between agent and server is via client authenticated HTTPS. There is no way, unless you enable automatic signing, that somebody can accidentally become part of your Puppet configuration. So the agent generates a private key. It fetches the CA from the server, and it sends its certificate signing request to the server. Then the server has the option of automatically signing that key. If you are in a locked down, entirely personally managed environment, say in HPC, and you know for a fact the only machines that will ever connect to that Puppet server is yours, enable automatic signing. You know what you're getting yourself into. Otherwise, you as the system administrator has to go to the server and manually sign that key. It's one command, but it has to be done manually. Otherwise, you might accidentally have the HR server, which somebody installed Puppet on because it looks like a nice tool, and which somehow got to your server. You might actually sign his key, and then he starts getting configs from you, deleting maybe HR. Wouldn't want that. Their second run. Okay, wait. So the agent then, so the agent sends the certificate signing request. It has the option of waiting for the server to sign it and return. So if you have automatic signing on, it can wait and then continue this process. Or you run this a second time, and then it'll get to the third option for fetch. It'll fetch its signed certificate, and then it'll initiate a normal run. A normal run looks like this. So the agent sends its facts and requests a catalog from the server. The server fetches all exported resources from the database. That part is optional. If you don't have exported resources and you don't have a database, that part does not happen. Exported resources are things that after a run, the agent says, well, I've got these things and they might be useful to other people. The SSH module specifically uses this, where the agent's host keys are actually given back to the Puppet database so that every single one of your other agents can get that host key to put into known hosts. All your machines can automatically trust each other because they all belong to the same Puppet environment. So they can all become part of the same known host file automatically because of this exported resources. So it fetches the exported resources. The server generates a catalog based on your configuration modules and optionally Hira if you're using that, and that is then sent to the agent. The agent then goes through the catalog, like, cool, I need to install cups, I need to make sure this runs, I need to do that, do the following things, and it applies that catalog. When it has completed, successful or not, it will report back to the server, and it will also send any exported resources if the server has let it know that exported resources are supported. The server stores that report, and the database also stores a report if you've set that up. Questions about the process so far? Cool. So on campus, um, campus would be my unmanaged environment. I generally do, unless somebody asks me for a specific OS, I install the latest LTS of Ubuntu. And I generally do that off a flash disk, which then pulls off ftp.sun, and I have a pre-seed that just installs the default desktop and the Puppet agent. That's all it does, and I sign the certificate manually because I don't trust the environment at all, and I don't accidentally want to overwrite anybody's machine with my idea of what it should look like. On the HPCs, it's a secure environment, which only I control, but also I spin up way too many VMs and I do way too many other things to enable, for me to feel comfortable enabling automatic signing. So I also have my manual signing there. So there I do a Pixie boot, much easier. Also do a network install, same pre-seed, and on my HPCs, I generally run Scientific Linux. And my configurations for campus and HPC are very, very similar. There is, in general, only, say, 1 in 20 configuration items that are different between the two. The biggest ones being the repositories. The one uses apt, the other one uses yum. Foreman is a really, really cool tool, which I'm currently not running. Um, it is an all-in-one system. Web front end gives you full reporting, very beautiful. It can be your Pixie environment. It can do DNS. It can do DHCP. It has the Puppet server and Puppet database at the back end, and it can do everything for you. Really, really awesome. It is just one step behind the latest versions of Puppet though. It takes them a while to get up to speed. So I don't have it in production because I'm waiting for the next version 1.12, I think, which should be out by September. And when they do that, I'll just be taking their reporting part. I don't need all the rest. I already have it deployed. Cool. So with that, we'll go over to a demo. Any questions so far? Cool. Am I? I broke it. Did I break it? No. Cool. So what I have on this machine, I've got two virtual machines running. So I've got my Puppet server. It's just a Scientific Linux 7.2 machine. And I also installed a Ubuntu Trustee machine. It's a clean install. The only thing that it has on is the Puppet agent. So clean, trusty with Puppet agent. It's just a normal desktop install like you would expect any normal ISO install to be. So what we're going to do is, I've got this trusty VM. I'm going to revert it to the snapshot so you can see I'm not cheating. And we're going to power this on. Now, while that's busy, I can show you what my environment looks like. Let's see if that works out. Thank you very much. Okay, so I have 3 environments. And the one that I'm going to show you first is the demo environment. So in this demo environment, I just have a common Hira file. And in this common Hira file, I literally only use one module. This is the NTP module as written by Puppet Labs, and I'm going to accept all defaults set in the NTP module except for those 3. I'm going to ensure that the latest NTP package that the package manager knows about is installed at all times. Therefore, every single time this agent runs, it'll check, is there a newer version of NTP available? I'm going to enable iBurst for my NTP servers. iBurst is just a setting which allows the NTP, the system time to be set really quickly the very first time NTP starts up. And I'm going to set these 2 random NTP servers that I found on somebody's site. And that's what my machine looks like at the back. Okay, so I'm just going to close this. Okay, so as I said, all communications is client authenticated HTTPS. So let's just see puppet cert list. I have a certificate which is signed, that's what little plus means, for puppet.miami. So that's my Puppet server. That's the only certificate this machine knows about. So I'm going to start up a, let's just do that. Which is better, white and black, black or white? Okay, so let's do this quickly. Never do everything as root, but this is a demo. Okay, I'm going to cheat because I have no DNS servers here and I need to tell it where my server is. I'm just going to add this quickly to the hosts file so it can actually find my Puppet server. And then I am going to tell it to connect to my Puppet server. So I'm telling it Puppet agent verbose, so you can see all the nice things in green. Run once, don't demonize in the background. Go to puppet.miami and request the demo environment. And as you can see there, it has, move that away, fetched the CA, and it has created itself a new CSR, which it has sent to the server. So on the server, I should see that there is a new certificate that is waiting to be signed, trusty.miami. So let's sign that quickly. Sign. Trusty. Cool. So that should now be signed. Now, I showed you that the only thing that I'm going to apply is NTP. So let's see. Do I have an NTP file? I do not. So my certificate has been signed. Let's run this again. So now it should fetch its certificate. It should fetch a lot of things from the server because it's the first time that it's running. Let's just move this up a bit. It has loaded its facts. It has cached the catalog for itself from the server, and it's applying the configuration. Now that means that it's going online to go fetch the NTP package from some Ubuntu server somewhere because I haven't set any of the package managers yet, and it hasn't been able to find it. Do I have internet? I do. Let's try that again. Maybe it just couldn't connect. Connection refused to ftp.sun. Yeah. Okay. Let's. Mm, Come on. Now I know, folks, never do a live demo. I was sitting here, back there, doing this yesterday. Worked perfectly. Come on. I think maybe my VPN is in the way. Let me just kill that quickly. Disconnect. Yes. Okay, go away. Okay. Just make sure that there is nothing in the background. What are you doing? Okay, let's kill that. Try again. Okay, it hasn't done that yet. Let's try that. Please work. Loading the facts again. Applying. Okay. So what it's supposed to be doing now is going to the FTP server, fetching the NTP package, installing it, which it did. Lovely. Package NTP ensure. It has been created. It then computed a checksum on the file etcntp.conf, decided that is not the content that it wants, changed the file, and then restarted the service. So now we can see that, yes, I have that file, and it should have those two random servers that I enabled, as easy as. So that's a really, really nice short demo. That's the way it works. What I'm going to show you now, and hopefully it works this time, is I'm going to convert this machine into just a random little campus machine. And one of the things it's going to do, can I move this just a little bit out of the way? So I'm going to have it enable LDAP authentication to my campus. I'm going to have it change the display manager to not give a list of users, not allow a guest session, not allow a remote desktop, remote login session. And it's going to install my campus printers. It's going to, what are the other things? All sorts of other updates. Yeah, so, but those are the main things that it's going to do now. So it's just a couple of more things to install that we wait. Who's using all the internet? And after a reboot of this client, we should technically be able to log in this VM with my campus credentials with one Puppet run, which yesterday only took 90 seconds. Today it's not. While we wait for this, any questions so far? Yes. When I started with, okay, so the question was, why did I choose Puppet over Chef, Ansible, any of those? 3 years ago, when I started doing the HPC, the only thing that I had that was readily available inside the repo of the OS we had at that time was Puppet. So I didn't want to add more complexity onto a very broken system at that time by rolling my own solution. So I took the Puppet that was there at the time. Um, and since then, I've just updated that because for me now to change over to something else would be even more work. And unfortunately, I'm the only person maintaining this, and I don't really have the time to even implement or investigate Chef, even though I've heard it's quite nice. So unfortunately, I can't give you any kind of pros or cons. So let's see what's going on here. As you see, it has restarted my display manager. The system administrator is gone. The guest login is gone, and it has changed the configuration of the display manager and restarted the service for me. As I said earlier, a lot of things will fail, and they have. As you see, it failed to install libpam script. It failed to install the OpenVM tools because down here is where it, for the first time, actually applied my repositories. So it tried to install things before I gave it the repositories. If you have your relationships in place correctly, that first error won't happen. So what's it still doing? It's okay. So it has updated all my repositories, and now it's just quickly running a apt update on those. As soon as that's done, I will be able to run this configuration again, and it'll go through the entire catalog again, and everything that has failed, it'll do. You can rerun the same config over and over until it succeeds. But obviously, if you write your configurations correctly the first time, it only needs to be done once. Come on, the internet's not that slow. So you can see here, just give you more idea of what I've done. I've set up sudo users. I have updated the Puppet config itself. We installed a color printer. We installed a normal printer. We edited the SSH configs to only allow a certain number of users. I have enabled SSSD, which is what we use for LDAP. NS switch, which is also part of authentication. We've added some cron things. Here is where we changed the light DM, the display manager. That's where it added that configuration and restarted the service for you. What else have we? We changed the NTP because I changed that NTP now to my campus NTP. So as soon as this is done, we can see whether it's done that. And the internet is really slow today. Other questions while we wait? You. Hi. For macOS. They, I haven't applied it on a Mac myself yet, but they do have official agents. Therefore, it is officially supported. Um, the last time I checked, it was all the way from 10.9 upwards. So at least the last 3 OSs are supported. But yes, I think it would work for you. It would even be able to combine Homebrew with this for you, because you can literally execute any exe you want. Any command line can be executed. Any file can be copied in, and you can install a package from anywhere. Sorry. Yes. Yeah. Um, if you deep freeze your machine and a Puppet run changes something. Yeah. if your users do not have root, you would be able to have your Puppet run every 30 minutes, and you would be able to tell it to execute all sorts of commands to automatically clean your machine again. So if you know for a fact that they put trash in /temp and the install files there, you can put in whatever cron you want to go look through that, clear that out. And we're done. Okay, so yesterday that was 78 seconds. Today that was 439. So let's just make it finish that last run quickly. There's just 2 packages that needs to be installed still. And at the end of this, we should have a fully working system. I should technically be able to log into the system by now, but I know for a fact that the services started or at least applied in the wrong order, so I won't be able to actually authenticate. So let's just finish this, give it a reboot, and I will be able to show you that authentication would work. That's 1 package installed. Come on, VM tools. Another question. Yes. Yes. Um, Again, I haven't tried it myself, but you would be able to deploy software with this if you don't have SCCM. You would also, for a non-domain machine, be able to set things in the registry. So if you know for a fact that you have machines that aren't on the domain for some reason, but you still need to be able to control them, you would be able to apply things to them. But there are other ways of doing it. Yes.
Okay. So just to add to that, if you want to use Puppet on Windows machines, if you don't have SCCM or MDT running, which you can physically deploy with, apart from just doing a deployment, you can also monitor services on a Windows machine, which SCCM does not allow you to do. So that's actually quite a nice, useful tip to use Puppet, is to monitor services on clients. And of course, also then make sure that it doesn't run any unneeded or unwanted services.
And then also um, users. If you know you have a specific user on a machine, you would be able to remotely set the password, that type of thing as well. But as I say, there are other tools already in the Microsoft stable for that. But as we all know, there are gaps. So let me just start up my VPN again quickly. I should technically now be able to log in if I can. Oh, that's why. Ooh, yes, no. Huh, that's a A. So please. Well, it's taken forever, so I assume it's working. So I have showed that in a number of minutes, which should have been 90 seconds, you can actually configure a machine to authenticate to your campus with only a small config file. So that's the nice part of that. So let me show you how I did that. So I showed you the config file for the demo, which was really, really small. It only had the one class in it. The campus one that I have, which is still is a stripped down version of what I use, my module list looks like that. So I can control the package managers of both apt and yum. I can do sudo. I can do SSSD, which is authentication. I can change the the SSH configuration on the machine. I can install OpenVM tools based on the fact that the client told me I am a virtual machine. One of the facts that you can actually check for the trustee, its SSH key changed. That'll teach me. Terminal. Okay, factor. It tells me it is a virtual machine and it's running on VMware. It also tells me the time zone, the system uptime. These are all the public keys of the machine, which are then exported, stored in the Puppet database, and can be given to other machines that my Puppet server also trusts. So they are all inside each other's known hosts. The version of Ruby, I put 4 processors in this VM. The partitions in this machine, a nice big part of what is the OS. And then based on the specific distro, the specific version code, you can go do specific things, as I'll show now. So that's factor. So based on those facts, I can install VM tools or not. I can change the NSS. You can change the firewalls. It's not a very, very good module at the moment because you have to write your firewall line with a number at the beginning just to make sure the order is correct. It's not that good yet. But the config file for this is slightly more extensive. As you can see, I have a nodes directory. In that nodes directory, I would be able to put something like trusty.miami.yaml, and then any configuration that applies only to that machine will come from that file. Anything else, it defaults over into Ubuntu, and if there's nothing specific there, it'll default over into common. So in my Ubuntu, I told it, yes, use the apt use the app module, and in in scientific, I told it use yum, and that unfortunately is my time. Thank you very much.
Thank you very much.
Like to end the conference on time. I'd just like to say a couple of things. For those that are first-time natives, all the speakers get a certificate of excellence for their contribution. So what's about to happen now is what we call our award ceremony.